Automotive electronic fuel injection found its way into motorcycles in the 1990s. BMW and Bosch technology was a good fit for road motorcycles, and by the mid-2000s, carburetors began disappearing from dirt motorcycles as well. There is plenty of controversy about the reliability and troubleshooting of EFI, but let's begin by comparing the basic differences between carburation and electronic fuel and spark management. Carburetors date back to the original internal combustion engines, providing a way to proportionately mix air and gasoline. In the right ratio, the engine can burn fuel thoroughly and efficiently. Ideally, the ratio for optimal burn at a cruise speed and steady throttle is 14.7 to 1 or stoichiometric. That's 14.7 pounds of air to 1 pound of gasoline. A cold engine needs a richer mixture to run properly. A hard pulling or accelerating engine also needs a richer mixture. Richer means more fuel, so the ratio might shift to 12 to 1 or so. A typical motorcycle carburetor uses either a mechanical means for controlling the air-fuel mixture or a combination of mechanical and vacuum signals that control the throttle opening and fuel metering. A fully mechanical slide-type carburetor is generally found on performance dirt motorcycles that require close attention to tuning. Vacuum signal or constant velocity carburetors are most often found on highway motorcycles. In this video, our concern is not details about carburetor designs beyond the fact that a motorcycle's mechanical slide-type or CV carburetor has no electronically controlled features. The purpose and advantage of a CV carburetor is smoother control of the throttle opening and a way to compensate somewhat for altitude. By contrast, a slide carburetor is fully mechanical. The jet sizing, the throttle-controlled slide, and its attached needle regulate the fuel flow. On a mechanical slide carburetor, the slide opens strictly by the throttle cable. On a CV carburetor, the rider opens the throttle valve mechanically, but the slide only opens when there is enough vacuum at the CV diaphragm. For the most part, the CV carburetor responds to engine load and available airflow to open the slide and needle. With a carburetor, the amount of fuel flow from an idle to cruise speed is controlled by the jets and slide needle position. Wide open throttle is the maximum available fuel flow. This always relies on the air intake volume when powering up the engine. At full throttle, the carburetor has enough incoming air velocity to draw fuel up from the fuel well or float bowl. This creates the air-fuel mixture that flows through the intake valves and into the cylinder or cylinders. Again, this process is mechanical and not precisely regulated. Now let's consider electronic fuel injection or EFI. With EFI, air intake is still regulated by the throttle opening. There is still a throttle valve similar to a carburetor. Here though, the throttle has two functions. First, it provides a signal from the rider demanding power and speed. Second, the throttle body sends a throttle position signal to the electronic computer module, or ECM/ECU. The signal comes from the throttle position sensor. The throttle valve can be opened with a traditional throttle cable or by way of fly-by-wire signals. The electronic control module receives several signals. Importantly, the throttle position sensor tells the computer how much engine power and speed the operator wants. The throttle valve opening allows air to flow into the intake, much like a carburetor. Some EFI systems precisely measure that airflow with a mass airflow sensor. Other EFI systems simply rely on the throttle position and stream of data from the oxygen sensor. EFI engines use an oxygen sensor in the exhaust stream to measure the oxygen present in the burned air fuel, leaving the engine cylinder or cylinders. The oxygen sensor provides a crucial signal to the control module. In milliseconds, the O2 sensor measures the amount of oxygen in the exhaust flow and sends the data to the ECM for finally adjusting the air-fuel ratio. The optimal adjustment for complete gasoline burn again is 14.7 to 1 or stoichiometric. If the rider opens the throttle to accelerate, the throttle position sensor lets the ECM know this. Depending on the demand, the air-fuel ratio will shift richer during acceleration. Once the rider's demand levels out, the EFI returns to 14.7 to 1 or leaner as soon as possible. This controls exhaust emissions far better than a carburetor. Mandates for lower emissions and better fuel efficiency have been a driving force around the spread of EFI within the motorcycle industry. EFI delivers fuel via an electric pressure pump and fuel injector. This is a precise way to control the amount of fuel entering the cylinder or cylinders. Coupled with the throttle opening and oxygen sensor readings at the exhaust, the ECM sets an exact fuel flow through the injector. The typical injector has a solenoid-actuated pintle that seats at an orifice. Fuel pressure is constant. The amount of time that the ECM holds the injector pintle open controls the volume of fuel flow. This opening time interval is called the injector's pulse width. Pulse width varies depending on the throttle demand, O2 sensor readings, coolant temperature, and sometimes the engine load. Internal combustion gasoline engine loads get measured as manifold vacuum. That vacuum applies at a manifold absolute pressure or MAP sensor. A coolant temperature sensor tells the ECM to enrich the fuel mix when the engine is cold. This is similar to the old mechanical choke valve's function. With EFI, the injector pulse width increases in a cold engine to enrich the mixture. It's that simple. An EFI system consists of the higher pressure fuel pump for the injectors, the injector or injectors, an O2 sensor in the exhaust, a coolant temp sensor, sometimes a MAP sensor, a throttle position sensor, and a crankshaft position sensor. The crankshaft position sensor, or CPS, is also the reference point for spark advance and adjustment. Spark timing management is an integral part of most automotive and motorcycle electronic fuel and spark management systems. Spark timing algorithms sync with the EFI system. So what are the advantages of a carburetor over an EFI system? A motorcycle carburetor is mechanical with no electrical or electronic needs. The carburetor controls air-fuel ratios and compensates for cold start enrichment mechanically. When the carburetor is set up and jetted correctly, with all passageways clear, there are smooth transitions between an idle, acceleration, and cruise throttle. Bursts of power are controlled by the throttle opening and the engine's ability to draw air-fuel through the carburetor. A choke valve for cold starts has an adjustable manual lever used for enrichment during cold starting and engine warm-up. Tuned properly, this all works well, although it's lacking EFI's millisecond response to air-fuel demands and precise control over tailpipe emissions. For the most part, a clean carburetor is fail-safe, easy to troubleshoot in the field, and reliable. Repairs can be made anywhere, usually with basic tools. Tuning can include jet changes and slide needle adjustment to compensate for altitude or riding styles. While the CV carburetor compensates some for altitude, riders covering a wide range of altitudes deal with jetting corrections on their slide carburetors. A cleaner, more complete burn from Enerpulse Polestar spark plugs has reduced this problem on my carbureted enduro motorcycles. See the Polestar review at the channel. Slide carburetors with a manual choke lever also take engine starting to another level. The rider needs to know the engine's cold and hot start habits. How much choke is enough? Too much choke will flood the engine. Too little choke means a cold, cantankerous startup. Without electric start, this gets even more complicated, especially with single-cylinder thumper engines. For a new rider, there's a learning curve for starting a carbureted engine. Downsides to carburation would be the jet size and needle requirements for altitude, the need to tinker with idle speed and idle mixture adjustments, especially on slide-type carburetors, and the lack of precision air-fuel ratios. There are many operating conditions where a carburetor wastes fuel. Power and throttle demands are not linear. A carburetor's fixed jetting size, The slide needle shape, airflow characteristics, including the air filter type and its porosity, and slide air leaks lead to a best compromise. A rich exhaust is wasted fuel. At the same time, the combustion chamber is likely to build up carbon. Carbon soot fouls the spark plug. As for electronic fuel injection, benefits begin with reducing the operator's chores. There is no choke, just the ECM controlling enrichment and idle speed. Changing jets or repositioning a needle is never necessary. The air-fuel ratios during idle, acceleration, cruise, and deceleration are precisely controlled by a fuel map built into the ECM's firmware. The spark advance curve and timing changes are each part of a spark algorithm. On more refined EFI systems, idle speed is electronically controlled with an idle air control valve. There is no tune-up routine beyond oil, oil filter, fuel filter, and spark plug changes, plus air filter service and occasional valve adjustment. The EFI engine does depend on a battery. A kickstart carbureted motorcycle, especially a motocross or enduro bike without street lighting, may not require a battery. None of our XR Honda R models came with a battery. EFI needs an electric fuel pump to pressurize fuel at the injector. Battery voltage is a constant requirement for the fuel pump. ECM, ignition and fuel injector, or injectors to start the bike and function. You cannot start an EFI motorcycle without an adequate amount of battery voltage to power the electric fuel pump, ECM, and injectors. Without a kickstart pedal, you can add electric starting to the list. EFI motorcycles have a substantial alternator, stator, and battery to meet the demands of EFI and electric start. ADV engines often come from street and sport touring bikes that were equipped with electric start and have no kickstart pedal. These EFI bikes depend entirely on the battery and electrical system to operate. You cannot bump start an EFI bike without enough battery voltage to power up the fuel pump and injector system. The best alternative for remote riding is to bring a battery backup or use a battery like the anti-gravity battery with built-in reserve starting. See the channel video on the Gaither Off-Road Kit for some ideas. A major advantage of EFI is its ability to compensate for altitude changes. This is done with the MAP, O2, mass airflow, and other sensors. A rider can leave sea level and travel cross-country to the Colorado 14ers without fiddling with jets or fouling spark plugs. All engine tuning is a matter of the software that controls fuel and spark maps. There are even high-performance aftermarket software tuning kits available that change fuel and spark behavior. On that note, the factory tuning is often less than desirable. In riding some late-model dirt bikes with EFI, I notice erratic throttle chop when backing off the throttle. A carburetor by design will decelerate gradually, as the Venturi effect keeps a small amount of air fuel flowing even after the throttle closes. EFI, to its benefit, can cut off fuel instantaneously. To its detriment, if the software programming is extreme, EFI can cut off fuel completely under deceleration. The result, a diving front end, much like applying the front brake. Given that manufacturers design the fuel maps in ECM software, it might seem strange that there would be this kind of behavior. However, cutting off fuel completely under throttle closure can lower tailpipe emissions and reduce fuel consumption. These are two mandated aims, and when done without consideration for dirt riding conditions, the result can be negative. The problem can be remedied with aftermarket software corrections and idle control changes. In a nutshell, troubleshooting EFI involves the bike's entire electrical system: starter, stator output, battery condition, ECM, sensors in the injector or injectors. Direct port injection on a multi-cylinder engine requires individual injectors for each cylinder, while many motorcycle EFI systems have throttle body injection. A single injector fits at or near the throttle body. In any case, there will be a series of interrelated sensors and devices that make up the fuel and spark management system. Fortunately, electronic fuel injector and fuel and spark management is for the most part reliable. Parts typically have very long duty cycles. Electronics, as always, either work or don't. Sometimes we're lucky enough to have an intermittent or telltale problem, and here a scan tool may help pinpoint trouble or pick up a stored code. Second-guessing what parts to carry on a global travel route could be difficult. A fuel filter, even a fuel pump, might be wise for EFI bikes. Know how to install these parts under trying conditions. At the channel, I will demonstrate preventive maintenance and tuning, plus a troubleshooting that can turn up a potential issue. With an oscilloscope, we can find troubles like an EFI fuel pump on the verge of failing. These concerns should be on every remote rider's radar screen. Carrying spare parts goes beyond a spark plug. As a final consideration, EFI bikes do not flood out when on their side. While none of us plan to lay a bike down, dirt riding does pose that possibility. A carburetor on its side will unseat the float needle and can flood the intake with fuel. Shut off the tank petcock as quickly as possible under these conditions. By contrast, an EFI system will not flow fuel if the engine is stalled or the ignition is turned off. There are subtle safety advantages to EFI. Summing it up, we can expect motorcycle EFI to expand its applications. At present, the only barriers to wide-scale use are cost and need. A smaller displacement motorcycle can still meet emission standards with a carburetor and CDI ignition. Use of EFI on a bike below 150cc displacement would likely raise the cost too much and squash sales. Meanwhile, EFI dual sport and ADV bikes have improved their versatility, making them seamlessly adaptable for any elevation. Recognizing that EFI and electric start are here to stay in new dirt and highway motorcycles gets us in step with the times.